This question says, measure the volume in the following graduated cylinders. And we have two different graduated cylinders, and we have our meniscus. So there's a few challenges here that we need to talk about. But briefly, I want to talk about what a meniscus is. So we're assuming there's water inside of this obviously fake graduated cylinder just designed to give you a question. Water sticks to glass more than water sticks to itself. So therefore, when you put water in a tube, what happens is the edges tend to be higher than in the middle, because here the water is near the glass and it sticks to the glass more than it sticks to itself. So what happens is you get this shape that looks like this, and the shape we call a meniscus. We always read from the bottom of the meniscus. So we would want to read this graduated cylinder here, not up here. And you'll note that with a real graduated cylinder, you can twist it. So what you want to do is you want to twist it so that your graduations allow for the bottom of the meniscus to be between the graduations. Obviously on a piece of paper, we can't twist this thing, right? But you can in real life. So this is basically that. The next thing we need to look at is, what are these non-labeled graduations? So it's really common in graduated cylinders for you to have some labeled graduations, often big lines that go all the way across, and then some smaller graduations that are still, we know what they are, but they're not actually labeled. And then often you'll have this bigger one that's in the middle between two larger ones. Okay, so you'll have two numbered ones, you'll have a big one, a slightly longer one in the middle, and then these littler ones like this. They're not all designed like this, it depends on the graduated cylinder, but that just gives you an idea. So our first challenge is to figure out what are these individual graduations. And if you've already got that figured out, great. But if you don't have that figured out, you can actually do it by math. So what you want to do is you want to take this minus this and then divide it by the number of spaces, because that'll tell you how many spaces there are between here and here, and therefore it'll tell you the value of each of these spaces. So in this case, we would want to take 60 minus 50 and divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then divide by 10. So we're going to have 10 divided by 10, and you may have already figured out that each of these individual spaces is 1 milliliter. Note that that's important because it's not 1 milliliter in this one. It's not always 1 milliliter. It depends often on the size of the graduated cylinder. So in this case, we have 50. So this is 1 more, 51, 2 more, 52, 3 more, 53. Now we need to decide how are we going to make this measurement within 53. So we know it's between 53 and 54. And the rule is we must have one estimated digit. So we know it's 53 point something. And we need to estimate how close this is to 53 relative to what it is to 54. So 53.1 would be very close to 53, and 53.9 would be really close to 54. In this case, I'm going to say this is about 53.4 milliliters. Note that if you said 53.3 or 53.5, yeah, that's reasonable. We might have estimated this slightly differently. If you were to say 53, that wouldn't be good enough because you wouldn't have one estimated digit. Additionally, if you were to say 53.42, that wouldn't be valid either because you'd have an extra estimated digit. There's no way for you to know if this is 0.4 or 0.42. You can tell that it's a little closer to 53 than it is to 54, so calling it 53.4 is fine, but you can't call it 53.42. And just to illustrate the point, you really can't call it 53.4136718376 milliliters, right? That's not valid because there's no way you can estimate all these digits. So the rule is you have to have one estimated digit. Let's look at the other one. In this case, we have here 3 and we have 4. So we could do the exact same math. You could see, because these are exactly the same picture, right? Just with different numbers. There's still 10 spaces between here and here. So in this case, we would do 4 minus 3 divided by 10, which tells us that each of those individual spaces is 0.1 milliliters. So if we look here, this is 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, 3.8, 3.9, 4. And that's a good way to check, just to make sure when you go by them, you get to the number that you expect. So each of these is 0.1. So this is 3.5, 3.6, 3.7. So I'm sure that this is 3.7 something. I now need to estimate one digit. Now to me, it looks like this is right about in between the 3.7 and 3.8, exactly in the middle. So my one estimated digit is going to be a 5, which is halfway between them. So 3.75 milliliters. Just like before, I can't call this 3.75413228 milliliters. I can't estimate a whole bunch of digits. But I also can't simply call it 3.7 milliliters because I know this is 3.7 and I know this is 3.8. I must estimate one digit. So the trick here is one estimated digit.